Hello, freecad community. Thanks for this great opportunity to talk about conda in combination with freecad today. My name is Lorenz Lechner, known as Lo with 3O at the freecad forum. So first, what is this presentation about? Um, First, there are instructions to use different versions of freecad side by side with conda, so having different environments side by side, conda. Then some instructions to deploy FreeCAD with conda and conda build. And in the end, I will explain some things about the bundles which are done with the conda packages. Bundles are basically compressed environments bundled together and shared as one file. The aim of this presentation is to provide a comprehensive overview of conda and how to package with it. So first, how did I get involved into packaging FreeCAD with conda? First, we started with, we were passionate paragliders, and we started to develop a open source Python program for paraglider design, which is called OpenGlider. Then we looked for a graphical user interface for OpenGlider. We chose FreeCAD and created a FreeCAD workbench. All this, in the end, we wanted to distribute the whole thing. So we found conda, which basically allows us to distribute on different platforms. And we created packages for FreeCAD, for OpenGlider, and for dependencies to allow users to use conda and install all these things side by side. So first, I want to start with a little graph which should explain the dependencies of FreeCAD. Here are the main dependencies. There are more, but this is only a illustration to get some feeling for what a package manager does. So we have FreeCAD in the middle, and FreeCAD depends on different packages. Any library or program can be packaged as a conda package. So we can see these dependencies also as packages. So we have OCCD, the geometry kernel of FreeCAD. Then we have Coin, the 3D visualization library. Then we have Boost, Qt for the graphical user interface, PySide, which is the Python binding to Qt, NumPy, which is a numeric library for Python, then Python, the programming language itself, PyV is the Python binding to Coin, and yeah, there are more, but you see there are these packages. FreeCAD needs these packages to work correctly. And all these dependencies also have dependencies too. So if you show the full graph, it will be much more complex. And yeah, the package manager, in principle, the package manager resolves or solves for all the dependencies to have the correct version. And so in the end, we have an environment where FreeCAD is installed and all the dependencies with correct versions. So basically, with the conda package manager, here I have two illustrations or icons. For on the left is conda, on the right is mamba, which is a newer package um, manager which should replace conda in the future. So you can choose either to use conda, which is not or which is less fast, or you can choose mamba, which is a faster replacement for conda. And with these package managers, you can create environments, which is the basic principle of the Conda or Mamba package manager, to create environments. And in an environment, you can install any package. So here we create a FreeCAD environment, and the package manager resolves all the dependencies and installs these dependencies. Um, Now, what can you do with the package manager? What are the commands you can use in the command line with the command line tool? Um, you can create environments. Um, you can remove or install packages. You can also remove environments. So you can remove environments, install packages after you have created an environment into this environment. You can update packages inside an environment, and you can activate or deactivate environments. So why to choose Conda Mamba? Um, I mean, there are a lot of package managers available for Linux, for example. But why do you choose Conda or Mamba? First, it's cross-platform, so you have the option to install it on Linux, OS X, Windows, on different architectures. Then it's cross Python. Multiple Python versions are supported by Conda, and also for FreeCAD, there are lots of dependencies we use in FreeCAD. Um, uh, Ready for the packaged via CondaForge. CondaForge is the community-driven packaging from for Conda. Um, and for sure, the environments is a great opportunity to test different versions of the same software side by side. So you can install FreeCAD 0.19 next to FreeCAD development version or other um, FreeCAD versions inside different environments. Down there, I have a quote from QuantStack. So modern scientific applications typically depend on a very large number of libraries written in various programming languages, ranging from Fortran to TypeScript, C++, Python, and so on. So we need to pin down substantial requirements to be able to share and distribute this application. So basically, Conda allows to distribute all kind of programs, and with the Conda package manager, it's possible to solve for libraries or packages which are correctly working together. So as I said, there's Conda and there's Mamba. um, the Mamba is basically the replacement for Conda, and yeah. So the question is, which snake should I use? Um, I would say I am in the last year or something like this. I choose Mamba as the package manager because it's faster. But in the future, it will replace Conda anyways, so it's not that big deal if you install Conda or Mamba. But yeah, the starting point is always minimal a set of packages, which is either Miniconda or Micromamba. You can choose either of them. Next slide, I have for the three main different systems, I have listed the ways to install the Micromamba. So you basically download a shell script and call this shell script. And the shell script includes all the packages needed for the minimal conda installation. So I am not going into details. I will share this slide or the slides anyways, so you can look up and yeah, but it's also very easy to find this these downloads in the via Google or something. So once you have installed Conda, you can start with creating a new environment. For example, here I have shown the way how to create a freecad environment. So we use the create command. So conda create. Then the option N is for the name. We name the environment freecad, and we want to freecad to be and all its dependencies to be installed. So we choose freecad as the package, as the main package we want to have installed in this environment, and we choose the channel which is ConnerForge. The minus C means means is the option for the channel. Or if you want the latest FreeCAD version, you can again use the create command to create the environment and install and choose FreeCAD, but now also list the FreeCAD labeled dev channel to get the latest weekly builds. Okay, now to some. So this was mainly how to use Conda for user, and now I would like to give some information on the packaging. So Conda packages are created with so-called feedstocks. A feedstock is a collection of files and instructions that define how to build the package for the Conda package manager. I will show later on how a feedstock look like. A feedstock contains instructions for continuous integration tools like Azure or Travis. Azure is the main continuous integration tool used to create packages for CondaForge. So, okay, this is the FreeCAD feedstock. We have here the recipe, and we have the continuous integration support. So first I will show how the recipe looks like. Basically, it includes two scripts, one for Windows and one for Linux or OS X. And it includes this meta.yaml. This is the most important file. So we look at this and you see we have a name of the package, a version of the package. Then we have some patches here, the download where we get the source of freecad. Um, then we have a build number. This is a number which increases with every new package you. Also, if the version doesn't change, you have to change the build number to make sure conda finds the newest build, the newest package when you create a new environment or update the environment. Then we see the requirements. We have build requirements. We have host environments, which are the main in, host dependencies, which are the main dependencies used for the build procedure. And then we have run dependencies, which are the dependencies necessary to run freecad. So as we see here, we have Qt, OCT, OCCT, then we have VTK, and some others, PCL, and so on, matplotlib. Yeah, this is basically the meta.yaml. You define the dependencies, you define where the source is downloaded, and some other stuff. And then the build script, I show the Linux build script. Basically, yeah, you basically here is listed the commands to build freecad. Here we have a lot of options because building freecad via conda, you need to it's a bit difficult. You can't use CMake without options. You need to make sure everything works within an environment. So you need to find some file paths, basically, where to install FreeCAD, where to look for libraries, and so on. Yeah, this is basically the build script. Basically, if it works out of the box, you just need to do CMake point like this, or point because we first changed directory to build directory. Okay, this is the build script. Now back to the presentation. Where's the presentation? Yeah, okay. I wanted to show something else. So this is the build script, and now we look at the SAE support. So we have here a list of supported platforms and Python versions. So we build for different platforms and for different Python versions. And this is used in the it's used when FreeCAD is built via the Azure server. So back here, so feedstocks are basically the feedstocks have the instructions how to build a package via continuous integration tools and upload it to anaconda.org, where all the packages are stored. Feedstocks are um, are a product of Conda Forge. So it's Conda Forge organize and uh, organize all these feedstocks. So in the next step, I would like to, so you have the option to build packages via the Azure servers, as I showed before, via the feedstocks, but you also can do this locally on your computer. And to do this, you basically use conda build. Um, yeah, you use conda build, which is also a command line tool. So conda build, and like it is here listed in the middle of the slide. So you change the directory to the feedstock directory, and then you can call conda build uh, point minus m for to choose the m for matrix, to choose the config file. Yeah, you choose basically the versions of first you choose your system to build for your system, and then there is other options like Python version or other dependency version. And once you call this, conda build will try to solve for the dependencies, start the compilation, and package the result into a compressed file. Yeah, so basically it's very easy to build locally, but you have to make sure that certain things are set up correctly. So building locally is a bit difficult, at least for the first time when you build freecad, for example. For further information about conda build, I have given here the reference to the conda build documents. It's yeah, you can read about it in this link. Next, I would like to show you what are migrations. So basically, migration means when there is an update of a library or a program of any dependency of FreeCAD, then there is a bot which tries to update all uh, packages which depend on the library which is updated. And this is only done when there are when the library is updated in a way that is not compatible with dependent libraries. Migrations are basically pull requests which are done via bot, as I said. And these pull requests try to update the dependent libraries on the new versions of the library which is updated. I will show you how this pull request looks like. Here I have, for example, for FreeCAD, rebuild for VTK 9.22. So this is a pull request from a bot, and basically what we see, FreeCAD fails for all the different Python versions and different systems because yeah, of some errors, I don't know. So you can look into this details, then you go to a few more details. Build not found, super. Okay, it's too old. But I have another example which I did. You can also do this manually without the bot. So here I tried to update the development branch of the FreeCAD feedstock to boost 1.78, Python 3.11, VTK 9.2, and also I tried to uh, create Linux RM and OS X RM to support these platforms, and also update to OCCT 7.7 and PCL 1.13. And yeah, we have a conversation. Werner helped me with this, but we didn't succeed it. So you see, only Linux and OS X is working here, and there are still errors with the other platforms. If we look at it now, it's hopefully it. Yeah, here we see the the output of the build, and basically what it says here, some error with um, for Windows there is an error with the update to the boost 1.78. Yeah, so this is how migrations work. You basically um, try to update to newer versions and have to fix these kind of errors that are occurring. So now, as I said in the first slide, I'm going to talk a little bit about bundles. Bundles are basically compressed files which include a full FreeCAD environment. So for the bundles, we first create a environment where we install FreeCAD and all its dependencies, and then we use some scripts to bundle this environment into app images for Linux, DMGs for OS X, and zip files for Windows. So with bundles, it's possible to skip the whole pitch I explained before, installing conda, installing and creating the environments, and it's possible to run FreeCAD directly. You just download the app image, DMG, or the zip file, and make it executable and run FreeCAD. Yeah, so this is the basic idea of bundles, and we provide bundles for the development branch of FreeCAD on a weekly basis. 2 times a week a new bundle is provided, and also we provide it for the releases of FreeCAD. So basically this was my presentation. Thanks for your attention. Thanks for all the people working for FreeCAD. Also thanks to the people working for CondaForge who helped me a lot with the packaging of FreeCAD and its dependencies. And also thanks for the opportunity to give this presentation today. Thanks and have a nice day.
Hey, what's